Okay, now that we've dealt with the one phone I forgot to switch off and the relative emergency, no pun intended, we can get back to where we were. So, I was just powering up this radio. I've set it to put out about 1 watt on just a ham grade power meter, so we don't know exactly where it was. And I've explained that we have our fundamental tones. This touchscreen is going to be the end of me, I swear. Go over there. Thank you. We've got our fundamental tones, we've got our IMD 3 tones, and our IMD 5 tones. So, let's see what the radio is like in terms of cleanliness. Each step here has been set to 10 dB. Now please bear with me because the screen is slightly tilted down to suit the camera. I'm trying not to touch the screen. 1, 2, 3. That peak is touching there, that peak is touching there. So we've got 30 decibels difference between a fundamental tone that's coming from our tone generator and one of the IMD products, in this case IMD3. We have, if you look over here, 40 dB difference between IMD5. Now that's actually a good thing because the stronger the further out products are, the more splatter you're going to cause. Now all radios to some degree, their transmit bandwidth is wider than what your audio bandwidth is. The general rule of thumb is that, you know, if you've got your audio bandwidth set to 2.4 kilohertz, you can expect about 3 times that used in your communications channel, especially if people are nearby. But anyway, I digress. The way to minimize that is to make sure that your IMD3 products are always the dominant ones. You never want your IMD5 or 7 or 9 or 11 to be your dominant ones. Now you might see here there's a couple of just little tones every now and again. They're quite quite far down. They're just little spurious products coming from either the computer or the sound card. I believe it's, in this case, the combination of the computer and the Yaesu SCU17 that's introducing them, but they don't matter because we're measuring the difference between our fundamental tones and our IMD products, and it's pretty clear which one's which. So, anyway, we've decided that IMD3 is 30 down. That's really, really good for a 12-volt radio. That's about what you'd expect. Now, that's decibel from a single tone. dBc is a technical term. So if something is negative 30 dBc, you will actually see that written up in an ARRL technical article as being negative 36. And the reason ARL will write it up as negative 36 is they're saying that this tone is down 36 dB of the combined energy of these two tones. So when you add the 700 and the 1900 tones together, you will get, they add to be 6 dB more. And so they're saying what's 30 there plus the 6 dB of your wanted energy, so it's 36 dB down. Most people measure it dBc because it's very easy to see on a scope. You don't have to do that additional math. But it's worth noting that if you see something in an ARRL article and it's written up as negative 36 or negative 30 or whatever, you can actually expect it to be, when you measure on your equipment, negative 30 or you know, basically 6 dB less than what the ARRL has written in their review. So that's sort of, well, the radio's crept up now to just a little bit over a watt. Let's increase it a bit more. We're going to go very slowly here. So now we're putting out, I think, probably about 4 watts. My meter isn't very accurate. It reports this radio at full scale as being 4.5 watts. This is an 818. And it reports a 817 as being 4 watts. So it's, you know, give or take a little bit. Basically, we've ramped the power up about 3 times. So let's have a look what we're at now. We've got we can see there that one of our peak tones has actually gone up probably about 3 dB. So if you think that if you sum the two together, you can see what I mean. And our IMD3, we can see they're actually symmetrical on both sides now. So it was always interesting with the 81X series radios that the left side IMD products at low power were always stronger than the right side ones. And I don't exactly know why that is, and I don't really care, to be honest. It doesn't matter. But we can now see that with the higher power output, we're at, let's call this one halfway. And that's my recording loop ticking over. That one's about halfway. This one's just under halfway. So we'll count 1, 2, half, 2.5, and we'll add 2.25. So we're at about 2 3/4 divisions. As I said, you can use the settings to make them more accurate. It's just this is easier for camera. So we can see that as we've raised the power level up, we're probably at, say, negative 27 dBc now. And you can see how that works. The other thing that's worth noting, and it doesn't affect the 81X series radios too much, but the difference between IMD5 and IMD3 for a solid state device, as you increase the power, the IMD5 always grows stronger relative to the IMD3. On a 100-watt transceiver, you'd actually expect IMD5 to be the dominant product at full power, but it doesn't tend to happen on the 81X series radios. But you can see it has increased slightly. Well, you've probably got 7 dB difference now rather than the 10 you had before. So let's push this up to full power. Now that's about full power for this radio. And we can see, so I'm going to say that's about 6 watts on paper. It's 4.5 watts on my meter, but we've covered that that isn't particularly accurate at the low end of the scale. And now I've got 1, 2, 2.25 divisions. So we're going to say at full power, it's probably about, let me do the maths, negative 23 dBc or negative 29 dB PEP ARL. And that's okay because this is a portable radio putting out a very small amount of power. So if your IMD products are 23 decibels down over your wanted transmissions, and your wanted transmissions are only, say, S6 when everyone's noise floor is S5, they're never going to see these IMD products. So as you go lower and lower in maximum output, IMD, even if it's not perfect, becomes less of a problem because people are less likely to hear it. It's only the guys that, say, run California kilowatts, and by that I mean well over the legal limit, into beams and things like that. It's only those guys, if they're not careful of their IMD performance, they will stick out like a sore thumb. So for QRPers, IMD performance isn't a huge issue. For people running barefoot, as long as you're not overdriving the mic or putting it into, quite a high gain beam, usually not a big issue. But for people who want to run a lot of power, just like a broadcast station, you have to be very mindful of your performance. So anyway, let's overdrive the radio now. Yuck. I can't even figure out what is AF overdrive, what is PA section overdrive. It just looks disgusting, doesn't it? So you can really see the value of even a cheap tool like an SDR Play in showing you when you're operating your radio wrong. Dial it back quite a bit, shall we? And you can see that's still well and truly overdriven. This is typical of, say, someone running all knobs to the right, shall we say. You can see that your wanted products, they've gained a little bit of power. They're up halfway to the next division, but your IMD3 is now only 15 dBc down. Your IMD 5 is only negative 20 dBc down, and all your other IMD products, your 7th order, your 9th order, your 10th order, they're all noticeable. That's the station splattering. And that's something you can easily pick up with an SDR play. Just like a cheap watt meter allowed people to easily tune their tube amplifiers and hybrid transceivers, an SDR play really gives you great station monitoring ability. And so that's why I love them so much and I promote them. Are they as accurate as a $50,000 Tektronix scope? Heck no. Are they very, very useful in allowing a hobbyist ham to clean up or to put out the cleanest signal they possibly can with their station and their budget? Absolutely. And it's as simple as, just dialing things back a little bit. Okay, we're cleaning that right up. Look at that. Now, I'll show you another type of test, which is a white noise test, which actually gives a better demonstration of how things change. So, 1 second. Stop transmitting. We'll open up Audacity. We'll stop that. We'll kill this. Tracks. Add new. Mono track. Generate. And where is it? Noise. We want white noise. We want the amplitude to be 0.9, so we're not overdriving our AF section, the digital section on the computer, or the AF section sitting here. We'll generate that. There we go. We can see there's a little bit of a gap there. Hold down Shift and click play. And are we looping or not? No, we're not. What are we doing? Click there. Shift space is the same way of doing it. There you go. You can see there's a little bit of margin there. And let's find out how that's going. All right, I'll start transmitting now. I'll dial down the power quite a bit. Oh, as I said, you've got to be very slow with these things. And I'll click here again. Where is it? There we go, got a bit more space. Now, what are we putting out? We're putting out about half a watt. And you can see that's our transmitted bandwidth. So that's the shape of the, it really annoys me. That's the shape of the Collins filter. And that's just basically random audio. Now, or random noise, as we turn it up a bit, we're still not actually generating enough power. We're at a quarter watt or something to actually see any IMD. It's actually in the noise floor of the SDR play, RSP2. So let's turn it up. Okay, now we're starting to see the IMD products. And once again, they're showing up first as a little shoulder there on the left side. That's just a characteristic of the 818. But you can see them here as well on your waterfall. That's where the waterfall is really useful, is it? Especially when you're doing a white noise test, it can show you, I guess, the intensity quite easily of your IMD. So that's at just over a watt. Let's push it up a little bit more. That's what we nominally call, I call about 3 watts, maybe a bit more, maybe 4. And you can see now that you've got shoulders on both sides. And so this is what a typical transceiver looks like in the frequency domain. Now, I like the white noise test because you can very easily see where your worst IMD is and then do the count. So I'll turn it down a little bit just so that it matches up nicely. A little bit more. Okay, so on the left side is stronger than the right side, so we count from the left. We've got 1, 2, 3. 3 divisions, so 30 dB, and we're just a little bit over the top division, so I've got better than 30 dBc IMD performance, and that's at, I think, somewhere like 3 to 4 watts. Now let's increase it to maximum power. And this is the best part about white noise, you can see visually how increasing the power affects your shoulders, and specifically the I guess, delta or difference between your wanted products and your unwanted products. And so I really love this methodology of testing because it gives you two-tone, lets you do a laboratory accurate measurement, shall we say. Now the SDR play is, I think, specified at being somewhere around 1 dB accurate in terms of accuracy. But we're not really interested in that. We're interested in seeing, as we crank up the microphone gain or the power, how our station performed in terms of IMD. Now, I've cranked it well and truly up too much now. My power meter's reading nice and high, but without monitoring my station, I wouldn't know that I am really splattering either side. Now, if I turn it down just a little, I still haven't lost much power here. I haven't lost any power on the meter, but my IMD performance is much better. And that's how, I guess, to wrap things up, how useful an SDR play can be as a station monitor. Now, I'll go one step further and I'll say, unless you're wanting to do, sort of measurements, I won't say laboratory grade, even though I believe this equipment is on par with entry level, technical college sort of equipment. Unless you're wanting to do reasonably accurate measurements, you don't need all of this stuff. All you need is an SDR play with a short rubber ducky antenna plugged into it. And you just tune it to the frequency you're transmitting on, and you look at your signal live. So as a station monitor, it beats out all those fancy tools. It beats out a trapezoid pattern. It beats out, the trapezoid pattern you used to see on the old station monitors. It even beats out some of the newer station monitors. I won't name any brands, but there are some quite nice and quite expensive ones. It beats all of those out because with just a single SDR play, a computer to do the processing, and a rubber ducky antenna, you can see what's actually coming out of your station. Now, it's even better to use the rubber ducky antenna than it is to have a sampler in line, because the sampler in line will only show you what the signal going into the antenna looks like. It won't show you the passive intermodulation distortion coming from your tin roof and between the sheets of metal and stuff like that. It won't show you that bits of your tower are being excited and also radiating and producing IMD, passive IMD in that way. So the most accurate station monitoring you can do is also the cheapest. It's as simple as an SDR play or similar low-priced SDR receiver with decent specifications. Always look for one that comes with a specification sheet. As I said, pay attention to how you've set it up, attach a rubber ducky, and you can tell what your signals, what your station's performance is really like. So if you have one of those days where there's really good propagation and someone says, oh, you're 60 over and you're splattering everywhere, your station's set up terribly, you're a monkey of a ham, you got your license in a cardboard box, you don't know CW, and all that sort of stuff, you can turn around to them and you can say, I'm watching on my station monitor right now. I can see that my transmitted signal is 30 dB down. In this case, it's not. I need to reduce it a little bit more. Let's go. There we go. I can see that my transmitted signal is 30 dBc down. Have you considered, Mr. Abusive Ham, have you considered the fact that the transmitter I own is specified as being best case performance negative 30 dBc, and the fact that my signal is negative 30 dBc? Have you considered the fact that maybe the only reason you're seeing splatter is because conditions are so good that you're seeing my IMD products? And that perhaps if you wound the RF gain back down a little bit, it wouldn't be such an issue. So that's one thing I like about it. It's the best $200 or whatever you can ever spend, because you can monitor your own real world transmitted signal And when those people come up and abuse you and pretend that they've got 3 electronic engineering degrees, they were in the military for 20 years designing radar, and they, well, I don't know, they taught at MIT and Harvard, and what are the nice ones in the UK? They were guest lecturers at Cambridge and all that. So when one of those hams comes up and tells you all that and tells you you're dirty, you can point out that if they did some simple math, they'd know that your station is clean. So I'm going to wrap this video up. There's a demonstration on how you can use a very cheap tool to do the job of a $1,000 entry-level spectrum analyzer, and why every ham should own one, in my opinion. So, 73 from Jarrad VK3 Bravo Lima, and Rate My Radio. Hope to catch you soon. See ya.